Okay, so the next thing we need to do is we need to look at the limits of trig functions. Now, the only thing we can use is that the limit as x tends to 0 of x over sine x equals 1. That's the only thing we can use. And the inverse of it, obviously, that the limit of sine x over x also equals 1. But what we can't do is, if this is the limit of as x tends to 0 of 2x over sine x, we've got to do a little bit of manipulation about that. Or if this was a 6x down the bottom here, we would have to do a little bit of manipulation, because it only works if this is x and this is x, or if this is 6x and this is 6x. So in this case, we might have to times the top by 3 to get to 6x and times the bottom by 3. Then we've got the limit as x tends to 0 of 6x over 3 times sine of 6x. And here we can say that the limit, this is just going to be 1/3 of the limit as x tends to 0 of 6x over sine 6x. And this is 1. This is 1 because we've got a 6x and a 6x. So this is just 1/3 of 1, which equals 1/3. And why could I take out this 1/3? That's one of those rules that you can, if it's multiplied by a constant, you can take it out of the limit. So let's have a look at how we do this. And I might need another sheet of paper. So what we're looking at is the limit as x tends to 0 of sine 2x over sine 5x. So just so I don't have to write the word limit as x tends to 0 all the time, let's just look at sine 2x over sine 5x. And let's manipulate that a little bit. So we know that that equals sine 2x over x times x over sine 5x. All I've done is times this by 1 over x times this by x, so they cancel out. So we get back to that. Now, as I said, what we really need is we need a situation where it's not sine 2x over x. We need a sine 2x over 2x, something like that, and a 5x over sine 5x. That's what we really need, and a 5x over sine 5x. So what we're going to do is we're going to force it. So for this first one, we can write this as sine 2x over 2x, and let's times that by 2. And again, those two things cancel out. And here we're going to do exactly the same thing. We're going to write up the top 5x over sine 5x, and we've got to times that by a fifth. Have we changed anything? This 2 can cancel with this 2, so we get back to here. This 5 can cancel with this 5, so we get back to here. So we haven't really changed anything. What we have done, though, is this is sine of 2x over 2x. Now what we need is to write the limits. So now I'm going to look at the limit as x tends to 0 of 2 times sine 2x over 2x, and we're going to times that by 5x over sine 5x, and we're going to times that by a fifth. And what this is the limit as x tends to 0. What happens to this thing? This becomes 1. What happens to this? It becomes 1. So what we get is 2 times 1 times 1 times 1/5, which is obviously 2/5. And that's it. Okay. The other one we might do is one that's a little bit more complicated, or at least looks a little bit more complicated. We've got the limit of cos x minus 1. Sorry, the limit as x tends to 0 of cos x minus 1 over 4x squared. So what, in this case, we've got a cos x minus 1, so we're going to multiply by the conjugate. So cos x plus 1 over cos x plus 1. And again, I'm not going to write the limits all the time. All I'm doing, imagine it's like that, all I'm doing is simplifying it. So because we've got the conjugate, we've suddenly got a difference of 2 squares. So this becomes cos squared x minus 1 on the top, and the bottom becomes 4x squared times this cos x plus 1. And we don't really know too much about cos x. If we went right back to the start and looked at this, as x tends to 0, cos x is 0. So, cos of 0 is 1. So 1 minus 1 is 0. When x equals 0, you get 4 times 0 squared, which is, so you get 0 over 0, and it all hell breaks loose. So we don't know too much about causes. So what we're going to do, and we've still got 1 happening here. So instead of writing cos squared x minus 1, if we remember that sine squared x plus cos squared x equals 1, then we should also know cos squared x minus 1 equals sine squared x. Sorry, the minus of sine squared x. All I've done there is taken the minus 1 over, or sorry, the 1 over become minus 1, and this becomes minus sine squared x. So this equals minus sine squared x over 4x squared times cos x plus 1. And we could expand that, but I'm just leaving it like that. And again, we don't need our limits because I'm not really doing anything. All I'm doing is simplifying it. This actually still equals that. I haven't even touched the limits. So let's expand all of this a little bit. So up the top, we're going to minus 1 times sine squared, sine x times another sine x. And hopefully it'll become obvious why I'm doing this. And the bottom's going to become 4 times x times this cos x plus 1. So all I've got is, if I wanted to write this out a bit neater, we get minus a quarter times sine x over x times sine x over x times 1 over cos x plus 1. Now, again, I haven't touched the limits. This is exactly the same as where we started. Now let's look at the limit as x tends to 0 of this thing here. Well, the minus a quarter stays as minus a quarter. Nothing happens here. As x becomes closer and closer to 0 here, that becomes 1. As x becomes closer and closer to 0 there, that becomes 1 because you've got an x and an x. As x becomes closer and closer to 0 there, you get 1 over 1 plus 1. The cos of 0 is 1. So what have we got here? We've got minus 1 over 1 plus 8. Minus a quarter times 1 times 1 times a half. Minus 1/8. And that's the way I would do it. Thanks.